this session, we'll provide an overview of what's new in the VMware Validated Design for Software-Defined Data Center version 4.1. It addresses the major changes to the design from the prior 4.0 releases. If you're unfamiliar with the VMware Validated Designs, check out the documentation at vmware.com/go/vvd-docs. My name is Ryan Johnson. I am a staff technical marketing architect in the Integrated Systems Business Unit at VMware, where my focus is the software-defined data center delivered through the VMware Validated Designs or VMware Cloud Foundation. If you have any questions about this presentation or the VMware Validated Designs in general, feel free to reach out to me on Twitter at 10:30 a.m. If you'd like to reach out to our product managers, our engineers, our architects, and many more, and ask questions, provide feedback on the designs, reach out to us on the VMware Validated Designs community at vmware.com/go/vvd-community. Let's take a look at what we'll cover in this session. First up, we'll cover the bill of materials. What software versions and components are used in the design update. And next up, we'll provide some insight into key design updates, their justification, and any implications. And we'll round it out with sharing some key resources to help you get started in this new release. So with that, let's get started and jump into the software bill of materials for this release. 4.1 release has an incremental wave of updates to the bill of materials since 4.0. And these include vSphere 6.5 Update 1, the most recent update to our flagship product and its components like the platform service controllers, vCenter server, ES6i, etc. VSAN 6.6.1, a major update to our industry-leading software-defined storage solution. NSX 6.3.3 for network virtualization, a fundamental element of the design that provides Layer 2 through Layer 7 network and security services in software. Site Recovery Manager 6.5.1 provides disaster recovery for the management stack and business workloads when implementing a dual region design. vRealize Automation 7.3, the cloud management platform and service catalog, self-service portal, blueprint creation canvas, governance, and third-party workflow integrations. vRealize Business for Cloud 7.3 is the integrated cost analysis and financial reporting for the private cloud. vRealize Operations 6.6.1 in the integrated management packs to report, manage, and forecast the health, risk, efficiency, and capacity across the SDDC. And lastly, vRealize Log Insight 4.5 and its integrated content packs. They provide an aggregation and analytics for the logs across the SDDC design. Now, I believe it's worth noting that both vRealize Operations and Log Insight now include the new user experience based on the open source VMware Clarity Design project. If you'd like to learn more about VMware Clarity Design or any of our other open source projects, check out code.vmware.com. And for a detailed list of the individual products, management packs, content packs, versions included in this release, refer to the design documentation and the release notes. Now let's do a quick side-by-side comparison between 4.0 and 4.1 release. And here you can see where vSphere has been updated from 6.5 to 6.5.update 1. NSX has moved to 6.3.3, that major update for vSAN to 6.6.1, and vRealize Operations Manager going from 6.4 to 6.6.1. You may also notice that there seem to be less content or less management packs listed for vRealize Operations Manager. I'll touch base on that a little bit later, but rest assured they're still there. And here we can see some other key cloud operations and cloud management updates. You'll see that vRealize Operations has moved from 4.0 to 4.5. You'll see we've added the content pack for vRealize Log Insight content pack for Linux is now in this design. You'll also see vRealize Automation, vRealize Orchestrator, and vRealize Business for Cloud have also had an incremental upgrade from 7.2 to 7.3. Now let's dive into the major design changes included in this release. And first up, we've made vSAN optional for the management pod's primary storage. So our previous releases of the design required vSAN as the primary storage in the management pod. And in this release, we've relaxed this requirement for the management pod. However, note that all of our functional testing and validation of the design is done using vSAN. And as in turn, the context of the design documentation is also done in the context of vSAN. So all the documentation uses vSAN, and all our functional testing and validation uses vSAN. And while we highly recommend the use of vSAN, particularly for this management pod, any supported storage may be used when using the design. However, we want you to be mindful that if a storage solution other than vSAN is selected, you'll need to appropriately adjust the design deployment and, of course, any day 2 operations guidance, since it's provided under the context of vSAN in the documentation. Additionally, that storage design must match or exceed the capacity and performance capabilities of the vSAN configuration in the design. All in all, we encourage the use of vSAN, but we want to ensure that you can use any supported storage that you've got an investment in. Now, in the same spirit, the VMware Validated Design now supports both Layer 3 and Layer 2 network transport services. But for the most scalable and vendor-neutral data center network, we highly recommend the use of a Layer 3 transport. So when you're deciding between Layer 2 or Layer 3, we do want you to consider the following. The first is that the north-south NSX ECMP edge devices establish their Layer 3 route adjacency with the first upstream device to provide equal cost routing for the management and workload virtual machine traffic. We also want you to consider the investment you have today in your current physical infrastructure and where you may be going tomorrow. And similar to vSAN in the management pod, all of the design documentation is provided under the context of a Layer 3 transport. So you'll need to appropriately adjust the design deployment and day 2 operations guidance under the context of a Layer 2 transport if you choose to use Layer 2. From a minimal design requirements, right, we have one 10 gigabit port on each TOR for the host uplinks, and the host uplinks are not configured in a lag or ether channel. The Layer 3 device must support BGP, but let's put a little asterisk there, and we'll cover that. We'll touch base back on that a little bit later in the presentation. And IGPM support is required for the NSX hybrid mode. Now, if we visually look here at Layer 2 and Layer 3 options for the network transport, let's have a quick conversation and talk about some of the considerations, possible benefits and drawbacks of using either Layer 2 or Layer 3. So let's first start with Layer 2 and some considerations. So the first consideration is that the top-of-rack switches and the upstream Layer 3 devices, such as your core switches or routers, they form your switch fabric. And the upstream Layer 3 devices terminate each VLAN and provide the default gateway functionality. The uplinks from the top-of-rack switch to the upstream Layer 3 device are 802.1q trunks carrying all the required VLANs. In terms of benefits, right, using Layer 2 provides you more design freedom because you can span VLANs, which can be useful in certain circumstances. But some of the drawbacks may be that the deployment size is limited and the fabric elements have to share a limited number of VLANs. And you may have to rely on a specialized data center switching fabric product from a single vendor in order to use the Layer 2. In terms of Layer 3, some considerations are that the Layer 2 connectivity is limited within the data center rack up to the top-of-rack switches. And those top-of-rack switches terminate each VLAN and provide default gateway functionality. So the uplinks from the TORs to the upstream the upstream layer are routed point-to-point links. The VLAN trunks on the uplinks are not allowed. A dynamic routing protocol such as OSPF, ISIS, or BGP connects the top-of-rack switches and the upstream switches, and each TOR advertises a small set of prefixes, typically one per VLAN or subnet, and in turn, the TOR calculates equal cost paths to the prefixes it receives from the other TORs. In terms of benefits and drawbacks, the VLANs are restricted to a single rack, and this can affect things like fault tolerance and storage networks. This limitation can be overcome if you use things like the Layer 2 bridging in NSX. And there's a wide variety of Layer 3 capable switching fabric products on the market today. So you can mix switches from different vendors due to a general interoperability between implementations of, again, OSPF, ISIS, or BGP. And this approach is typically far more cost effective because it makes use of only the basic functionality of the physical switches. Now, if you're familiar with the VMware Validated Designs, you're also familiar with the distributed management workload, or the two-pod architecture that we introduced a little while back. And the whole concept here is there's functional roles within the software-defined data center. Functional roles of management, edge, and kind of compute or workload, right? But management provides the location of where all your SDDC management pieces lie, right? Your vCenter service, your platform service controllers, NSX managers, controllers, vRealize operations, automation, log insight, etc., all running in this construct of this management pod, right? They also heavily use NSX for providing things like moving workloads between one region to another by using the capabilities of stretching layer 2 from one region to another, as well as distributed logical routing, etc. Now, workloads, they run over in a initial shared edge and compute pod, right? And here we provide edge services for north-south access for the SDDC workloads. We also provide things like load balancing or on-demand networks in this shared edge compute pod. And this is also where the compute workloads run. But at some point, as an organization grows, right, you've got this two-pod architecture, and you have investment for management, you have an investment for shared edge compute, and you grow, your organization grows and adding more workloads, you can add additional compute pods and stretch those networks over to these other pods. But one thing that we've heard from a lot of customers, they love the standard architecture and these specific functional roles, and it makes a lot of sense. It's got great use. But some customers have specific projects or specific use cases where they say, this is great, but I need a small location to deploy or a small project where I want to deploy a more consolidated environment, right? How can I put all these functional roles of management, edge, and place for my workloads all in one functional area? And we've heard that from our customers and partners in our field, and we're happy to announce that in VMware Validated Design 4.1, we're introducing the consolidated management and workload option, or one pod, as we sometimes refer to it. This gives us the ability to consolidate the management, edge, and workloads, all functionality, all into a single construct. And it only requires a minimum of four ESX hosts. And all the functional testing and validation of the design is done using vSAN. Again, like I mentioned, any supported storage may be used. You just need to adjust the deployment and adjust your day 2 operations as needed if you choose to use something other than vSAN. Very much like that, I mentioned earlier, both we support layer 2 and layer 3 transport services, but we do recommend for scalable and vendor neutral network, consider using a layer 3 transport. And this is also built so that it's ready for scale, right? So we can start with a minimum of 4 hosts, like I mentioned, and it's expandable up to a total of 32 hosts within the consolidated management and workload. That keeps it within the constraints of NSX's tested limits of a 32 node cluster, and allows you to grow from, say, using a 100 virtual machine, minimum 100 virtual machines, for example, up to like 2,500 virtual machines in terms of scale numbers. One of the cool pieces is, as in with any design, we use vRealize operations and log insight and, vRealize business and vRealize automation for all the operations and cloud management portions. But we want to be able to do that in the consolidated architecture, but not so big as in the fully distributed deployment. And what we've done in the consolidated deployment is we've built these that they're easy to scale, they're ready to scale by using a combination of their native functionality, right, where they have an integrated load balancer or integrated high availability, or using the constructs of using NSX Edge Services gateways, providing load balancing capabilities, and pre-configuring those application pools and server pools and rules automatically so that you can easily scale your environment. And we'll talk about that a little more in the upcoming slides. We also want to make it possible for you to move as your organization grows from a consolidated management workload, this one-pod architecture. If you outgrow this, give you the ability to move to a 2-pod. Maybe you want to add an additional site, additional region or location. Give you the ability to move to a 2-pod architecture so we can start to connect these two environments. Because in the design, we've only built this consolidated management workload for a single region and a single availability zone, which is really cool because it also gives you a little more flexibility on your licensing for NSX, because we're not using universal objects. So we're not having to have, use universal objects, say, for example, stretching our layer 2 and having universal distributed logical routers across regions. So it's only for a single region and a single availability zone today. Now, if you look in the construct of the context of the cluster design here, right, we can see that the management virtual machines, again, the vCenters, PSCs, NSX managers, controllers, vRealize automation, operations, etc., as well as the workloads, all run on the ESXi host in the consolidated cluster, right? We create specific reservations for things like our edge services as well as our management, so we can ensure that they're going to run solidly. And then the compute workloads can use the rest of the resources, right? So that you can run your applications. And here like I said, we require 4 hosts, 3 hosts because we're using vSAN in the documentation and testing, right? 3 hosts are required to provide N+1 redundancy to vSAN. The 4th host is used to guarantee that N+1 for vSAN redundancy during times of maintenance. So, for example, using vRealize, you're using Update Manager, right, to do rolling upgrades. We want to ensure that you have the ability to maintain that redundancy for vSAN during those maintenance operations. Again, you can scale from using a minimum of 4 hosts all the way to 32, so we have that scalability. In terms of NSX, I mentioned we deploy NSX. We use NSX heavily, but we deploy our NSX controllers for the control plane in terms of 3, as they would any good design. But we make sure we have anti-affinity rules so that those controllers land on separate hosts. And again, we have that 4th host in case we're doing maintenance. We still have a 4th host for those machines to move to. And in terms of each ESX host, we're kind of looking at around 200 virtual machines when using vSAN, 200 virtual machines per host when using vSAN in this design. Now, if we look at the consolidated management workloads, logical and physical design of vRealize Operations Manager, recall that vRealize Operations is used to pull in information and metrics across our SDDC. The whole point for it is to be able to look at the health, risk, efficiency, do capacity planning, help us figure out how our SDDC is running, right? Its core central function is monitoring and alerting, right? And we connect to things like vRealize Automation, our NSX, our storage devices, vSAN, even third parties in order to collect those metrics. Now, we want to make sure, again, that we can allow customers to start small and be able to grow their SDDC with their environment, right? Instead of going big, let's start at a good size and give them the ability to grow. Whether it's 4 nodes to 32 in the consolidated management workload, give that option, but not having to do a whole lot of upfront, a lot of management. How can we simplify this? And so in the consolidated management workload, we start, instead of using 3 nodes as in the distributed, we use a single 1-node medium-sized vRealize Operations analytics cluster. And this topology gives the ability to add nodes later. We can add high availability, we can scale out the nodes, we can add some failover. But we start with 1 node, put it behind an NSX edge service gateway in order to access the UI. As we find that we want to add high availability, we want to add more data nodes, we can expand that out up to the total max, but put anything behind the load balancer to distribute even the user sessions for the administrative portal or the dashboards. Now, in terms of the collecting the information, we use the construct of the vRealize Operations Remote Collector. And the vRealize Operations Remote Collector basically collects data from data and metrics from different adapters. Whether adapters are connecting to vCenter Server, NSX, vRealize Automation, vRealize Business, vSAN, etc. It talks to those devices, pulls it into their adapters, the metrics that we're wanting, and on a periodic basis, it will send that back to the analytics cluster to process, so it can kind of do things, again, calculate risk, health, efficiency, capacity, and then present those in a dashboards to users. So the whole point here is we want to give customers the option to start small and provide them a path of easy growth. Everything's been designed so it's it can be highly available and can scale with your organization. So we'll do all the pre-work and allow you to scale with your organization. In a similar way, we kind of do that with vRealize Log Insight as well. So if you look at the logical design and data sources for Log Insight, recall that Log Insight's used to do log aggregation, right? Pull logs in and then do analytics against those logs. So we can actually find things like the last mile of root cause, what caused an issue in an environment, be able to send logs from not only the SDDC management components, but also be able to send logs from our workloads if we choose to do so, either using native syslog or using the ingestion API for vRealize Log Insight. Log Insight has this ability to connect to our core SDDC logging clients like NSX, vCenter, platform services controllers, and others, right? VRealize automation, VRealize operations. And the point is now we're able to pull that in and we can analyze those logs. It also has an integrated load balancer built in. It's native, built in, and we're using that when we deploy it in the consolidated architecture. We're using that integrated load balancer. That means that basically as the organization grows and you need more capacity, right? More logs are being sent, not just from the core basic aspects that we need for the management infrastructure. You've got applications, you want to send native syslog or ingestion API logs in order to create beautiful dashboards for those. You have that option. You can add additional worker nodes to the vRealize Log Insight cluster and be able to scale that out as your organization grows. Now, if you're familiar with vRealize automation and the prior designs, we had a distributed design and the distributed management workload. And if you're familiar with vRealize automation, there's kind of these two sets of components, if you will. The core vRealize automation appliance, where we have things like the core services running for vRealize automation. We have VRO running inside. We have that's vRealize orchestrator. We have the VMware Identity Manager, as well as additional Postgres databases that are used for the construct of vRealize automation. We also had some other components called the IaaS, or infrastructure as a service components, that run on Windows boxes. Those are things like the distributed execution managers, distributed execution workers and orchestrators, the IaaS manager servers, proxy agents, etc. They kind of run separately, and it was in the distributed management workload two-pod architecture. There's lots of them, right? Everything's completely highly available design. Well, in the consolidated management workload, we want to allow you to move to that, but we don't necessarily have to have all that management overhead. We can start a little smaller and give you the option to move forward. So in this deployment, we have deployed it with a very minimal set of components we need. vRealize automation appliance, right, for VRO and VIDM and the databases that we need. We have the IaaS components. We have an IaaS manager. We have the DEMS, and we have the proxy agent. Very minimal set that we need to run it, but we have put it behind the NSX Edge Service gateways. They're highly available, but provide load balancing services. So all the pools, all the virtual servers have all been created, and we're allowing you the ability to start small, add additional appliances or IaaS components as you need to grow with the organization, as you scale from a small 4-node environment up to 32, or even if you want to move to the full two-pod architecture later. We give you that ability to do that in this design. And if you look at a high-level deployment architecture objectives between the two-pod and the one-pod here, in terms of really the minimum here is shown using the single site, single region, I should say. The minimum host are 8 nodes on the two-pod, right? 4 nodes to start on the one-pod. Whereas you have a lot more management VMs on the two-pod architecture. Everything's highly distributed, highly resilient. We have around 240 gigs of RAM required, 2 terabytes of VSAN, and 6 terabytes of NFS. We're aiming for around 50 to 70% less resources in the one pod. So we'll make that a lot smaller so you can have more resources available for the compute workloads. We deploy this for those specific use cases. I mentioned recoverability, right? The standard architecture for the two pod is dual region capable, and the one pod is a single region. But you could also do DR to cloud, and we'll talk about that a little more in a minute. If you look in terms of the modularity, this is one of the things I really think is important, is we provide modularity because you can kind of move from having a foundational approach to doing additive components. So you could deploy the foundational components of the vSphere, the vSAN, the NSX components of the design, and later come back and add the operations components or the cloud management components, right? Or you can do it all at one time, obviously. But we want to make it component based or modular if a customer needs that. And expansion options I kind of touched on already. If you are using the two-pod architecture, if you're familiar with the design, you add additional compute pods, as we talked about a little earlier, as you grow. In terms of the one pod, again, you can expand from 4 nodes all the way to 32, and if you want to go from there, you would transition to the two-pod architecture. What I want to call out here is some of the licensing options, right? And kind of have it broken out to like individual licensing or bundling. But the key point here is that these items that are in bold blue here. In the standard two-pod architecture, right, we have NSX for Enterprise, because NSX for Enterprise is used because we need to have the ability to do things like cross vCenter NSX, right? Or we have dual regions where we want to stretch the layer 2 from region A to region B. We also have Site Recovery Manager because it's a dual region, and we may be doing disaster recovery from region A to region B, or vice versa. And the whole point here is, at this point, we need those higher level licensing options. On the one pod, because it's a single region, we're not going to be stretching on our layer 2 elsewhere. We're not doing cross vCenter NSX. We can use NSX for vSphere Advanced. We don't have to have Site Recovery Manager because it's a single location. However, you could still add Site Recovery Manager to the one pod if, for example, you want to do disaster recovery to the cloud. Now, if we touch base on the management packs and content packs, I kind of alluded to this a little earlier when I first started talking about the bill of materials. So we're using vRealize Operations 6.6.1 and its management packs. And when I showed some of the versions, some of them were missing, and there's a reason for that. Previously, when you deployed vRealize Operations Manager, you had to do some post-deployment for certain management packs. Things like the management pack for VSAN, right? You had to deploy that manually. So now in version 6.6 and later, you can see that some of the management packs are actually deployed with the product. Right? They're embedded into the product. So one thing to call out, like the management pack for vSAN, the management pack for vRealize Automation, and the management pack for vRealize Business for Cloud are no longer separate post-deployment items. They're built into the product deployment for vRealize Operations 6.6.1. So you see management pack for vSAN, vRealize Automation, as well as vRealize Business for Cloud are built in. In terms of the content packs for Login Site, you kind of see a similar thing over here. Specifically for the content pack for Virtual SAN or vSAN is now embedded into the product deployment. And you also see post-deployment, we still have things like the NSX for vSphere, vRealize Automation, Orchestrator, and SQL Server content packs. But we've also added the content pack again. The content pack for Linux is new to the architecture. And if you're familiar with the way we have previously deployed vRealize Automation in the prior releases, you would recall that we had vRealize Automation appliances, right? We deployed, a set of those, put them highly available, and we had a separate set of appliances for vRealize Orchestrator and for our third-party workflow integrations and such. But what we've seen is a lot of customers moving to and guidance from our management business unit on what we can do to kind of reduce our footprint, right? And also get better performance on vRealize Automation. And to that end, you'll notice in this design, we've taken vRealize Orchestrator and we're now pulling that into the appliance because it's built into the appliance anyway. So instead of deploying separate appliances for vRealize Orchestrator, we now have an embedded vRealize Orchestrator instance in the appliances, right? This has actually given us better performance for the workflows, as well as give us more resources back to run compute workloads because we're not having to dedicate those to management. We don't have to have the separate appliances just for manage the separate appliances just for vRealize Orchestrator. We have a little bit less. We consolidate it, embed it, and we get better performance, and we save some footprint on CPU and memory in the design, which is fantastic. And if you're also familiar with the VVD and some history here, you're probably familiar with CertGen VVD. It's a tool that saves you time when you want to create the signed certificates. Right? You can check out Knowledge KB article 214-6215 for access to CertGen VVD. But the point here is that CertGen VVD gives you the ability to change their certificates, specifically in the VMCA for hybrid mode approach, where we're taking we're changing the certificates for user-facing services and replacing them with a signed certificate from a CA. And for more of the internal workings, things like vCenter solution users and ESXi certificates, we're using those that are issued from the VMCA, the VMware Certificate Authority. Now, one thing to note is that in this release, we're now adding a 2-layer certificate authority. So now we can support two layers, which has been a big ask. And in addition, people have had questions of, well, what happens when my certificates expire? Or I'm required for a reason to replace certificates in my SDDC. What is the process to do so? Can you help me make that easier? And I'm happy to say that between releases, between 4.0 and 4.1, we've actually provided certificate replacement guidance in the documentation. So if you need to change the certificate across your SDDC, the guidance is now there built into the documentation. Now, to get started, I want to leave you with some easy ways, some easy resources to get started with the VMware Validated Designs. The first up is our documentation. It's always the documentation. Go to vmware.com/go/vvd-docs. You can access our documentation anytime. And it's provided in both HTML form as well as PDF. So if you want to take it on the go, you can download it as PDF. You can highlight it, mark it up, and such as much as you want. But it's available in PDF as well as doing it on HTML. So you can browse, search, bookmark key aspects. I will note that we are planning to move that to docs.vmware.com in the future, just like a lot of our other documentation. If you've seen that platform, that is planned to eventually move. But this URL, vmware.com/go/vvd-docs, will always take you to the right landing page. Professional services, if you are a customer or a partner interested in professional services or providing those professional services, take a look at vmware.com/go/services to learn more about what we offer for the VMware Validated Designs and service delivery kits for our partners. And lastly, I'll mention again the VMware Validated Design community, vmware.com/go/vvd-community. For our product managers, our engineers, our architects are monitoring and watching those, and we're happy to take your feedback, your comments, your questions on the VMware Validated Designs anytime, because we want to hear from you on what you think about the designs and what you'd like to see in the designs. A few more resources that are available to you is our main site, vmware.com/go/vvd, for everything VVD. Documentation I mentioned, we have a poster that has been updated. You can always get the latest poster at vmware.com/go/vvd-sddc-poster for the latest poster. I mentioned the community. We have YouTube videos, vmware.com/go/vvd-videos. And if you're a vExpert and you'd like to ask questions on Slack, because that's your method of choice and you want to ask questions, if you're a vExpert, check us out on vexpert.slack.com under the VVD channel. There we monitor that. We're happy to answer questions on the VMware Validated Designs anytime. So thanks for attending this session on what's new in the VMware Validated Design for Software Defined Data Center 4.1.